Dogs love motion, and so do people. It can be lots of fun. But it's not so fun if the motion is from buildings or bridges like the Tacoma Narrows in 1940, when a steady wind caused the deck to twist and collapse into the waters below. Whenever there's a big structural failure, there's always a detailed study as to its cause. Except on 9/11, when even the most basic motions were never explained in the official investigations, like the smooth downward motion of the upper floors in the towers, and all the outward motions. Acceleration and the net force are proportional in accordance with Newton's laws. And while the force may be invisible, the acceleration is not. If there's no acceleration, we say there's no net force, even though there can still be motion. The direction of acceleration is always in line with the direction of the applied force. We can also determine the sequence of applied forces, that is, which force must have come first to cause the motions observed. And even totally different objects that move in a similar path will also have the same direction of net force. So any objects that have similar accelerations will have the same direction and the same sequence of net force, and is independent of scale. Mathematical equations were developed to explain some of the basic motions in nature. Later, computer simulations, which are based on mathematics, were developed. But sometimes, if the equations are not applied right, it can result in wrong conclusions. Or, as Tesla said, "Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality." And very small changes in the input parameters of computer models can have very different results. So any theory or simulation must be compared to experiment, which is central to the scientific method. Richard Feynman taught this.
If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
And so, computer simulations must be constantly refined and allowed to run long enough until it matches reality. There are some very good simulations, and some really bad simulations because they don't run long enough, and of course, they don't match reality.
Which led to a single column, one column that had a large unsupported length. And that one column, the critical column, buckled.
But when asked, how could he be so sure the Building 7 model was accurate?
And to use a very complicated computer model for this, how can you be so sure that this is actually accurate what you want? It's a virtual proof, some might say.
Well, computer models these days are incredibly robust. We actually design 1,000-foot, 2,000-foot buildings today purely based on computer models. We design airplanes that fly with computer models. We certainly can do failure analysis using computer models.
Well, we know what computer models can be used for, but that doesn't mean they're accurate. We use physical models all the time, and it's from those physical models and observations where the math and simulations are developed, never the other way around. There were two primary theories that were promoted, the pancake collapse and the pile driver collapse. Both rely on gravity to be the driving force for the two motions. In other words, the force and motions were down then out. Let's conduct some experiments to verify this. But first, we need to understand some basics about building design. There are two fundamental parameters of structural design. The first, of course, is strength. Obviously, each component must be able to hold the dead load plus the live load plus a significant factor of safety. And the second is what's called serviceability. The structure must be able to support all the loads without excessive deflection. For example, the building can't sway in the wind or have bouncy floors, even though it may be perfectly strong. Building codes have an allowable deflection, and for the towers, it's the beam length divided by 360, or L over 360. Ideally, any experimental model should meet these two basic requirements. The pancake theory, where gravity drives both the down and out motions, was promoted by FEMA and the American Society of Civil Engineers. PBS showed us a computer model demonstrating how the floors will continually fall down. But is that right? To test this, I used some cement-type planks and a solid block of steel that weighed about 20 pounds. Placing the steel block on the cement board, I measured the deflection for various numbers of planks. The plank span is 19 inches, and the maximum allowable deflection is therefore 19 divided by 360, or 0.053 inches. So the minimum number of planks needed to meet deflection criteria would be 4 planks for that particular design load. I built a tall support structure so I could test the theory, hopefully confirming the PBS model. Dropping the steel block first on the floors that met code deflection yielded a very different result. So I reduced the number of planks which didn't meet deflection criteria, and still the block decelerated and eventually stopped. And then it stops. In fact, dropping the steel weight on realistic supports always resulted in a deceleration and not an acceleration like we were led to believe. So the pancake collapse we were told by the American Society of Civil Engineers and the media,
Wrong.
which may be why NIST said, NIST's findings do not support the pancake theory of collapse. A mathematical paper explained that the upper, lighter part of the structure crushed the larger, stronger, and lower part all the way down to the ground, and then the smaller section crushed itself back up. Like the pancake theory, the piledriver theory relies on gravity for all the motions observed, and hence is another down and out theory. But is this possible? Using the same cement planks, I made some small floors that could be reused over and over. I had to build a steel guide rail system, otherwise the top section would continuously fall over. I decided to use some weak plastic pizza cover supports as my columns. Dropping about 15% of the floor system on the lower structure always demonstrated a deceleration. I even removed the upper plastic supports to make the falling floors denser. But it still didn't match the observed motion and never experienced the crush-down, crush-up result predicted by the equations. So I decided to make an unrealistic model where the supports were turned sideways and even weaker. The deflection was excessive, and just like the 9/11 Commission, they were set up to fail. Finally, it looked like I was starting to get the motions observed. But when we slow the action down, we can still see that the upper floors always decelerate, and we never see the crush-down, crush-up motions predicted by the piledriver theory. The columns in the towers were thicker and stronger below. But in order to give benefit to the piledriver theory, I wanted to make the weakest walls possible, even if it didn't meet deflection codes. So I used paper and matchsticks for my walls. Raising the upper floors and dropping them on the lower floors, I didn't get the results I was looking for. Instead of accelerating down like Tower 1, the upper floors decelerated, even on the weakest of supports. But did you really think the top floors would accelerate down through all this cold, strong steel by gravity alone? You knew it had to decelerate, otherwise we would never jump into the water. But since the towers were burning, I set my model on fire in the hope of replicating the motions observed with them. Unlike steel, my paper walls burned until they could no longer support the dead loads, and then began to accelerate, but soon that downward motion was arrested and then stopped, until the fire weakened the next paper wall. This continued for quite some time, but never did I witness the acceleration and total destruction of the entire system like we did on September 11th. No practical experiment has ever demonstrated the down and out motions observed using the pancake or piledriver theory. But what if our assumptions on the sequence of force are wrong? What if it wasn't down and out? What if instead it was out and down? It was time to try something else. Placing a firecracker inside the paper wall, I stacked my model floors, and even though it crushed the paper exceeding deflection criteria, it still supported the floors. In each test, the horizontal motion was first, followed by the downward motions. Out and down. Out and down. It looked like I was onto something, but I needed more explosives for my controlled demolition. Placing the firecrackers in each floor and connected by a long fuse inside the structure to each one, I stacked the system upwards, leaving the fuse accessible. I lit it, and I ran. While not perfect, it looked like I was starting to replicate the motions we observed with the Twin Towers. I tried various fuse lengths, lighting them in the upper floors in an effort to mimic the tower's motion. The problem was I was using basic fuse and firecrackers, which are very difficult to time and control. But if I had remote control wireless detonators, I think I could replicate the motions they saw.
Floor by floor instead of popping out.
It was if they had detonated.
Yeah,
if they were planned to take down a building. Boom, 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 boom.
And we can clearly see too. Sometimes I cut my fuse just a little bit too short. Even so, we can still learn much from my crude experiments. Notice that as soon as the walls are blown, the top uniformly accelerates down, just like the towers. And when there's a delay, the top's downward motion stops. It can't continue the downward motion until the walls blow. Out and down. Out and down. And out and down. My little firecrackers didn't have the energy to take down my core columns, like they took down the tower's spire. And of course, I still had floors, but Ground Zero had no floors at all, so they must have used very powerful explosives. But the force from the pancake and piledriver experiments doesn't match the motions, and therefore it's wrong. Yet my demolition experiment did. Nature is telling you that the mainstream media has been lying about 9/11 all along. Which may be why they hid behind their curtain of lies, using complex math and computer simulations rather than real experiments. But the ghosts of 9/11 will forever haunt the engineering and academic world because nobody, FEMA, ASCE, NIST, AIA, engineering organizations, university scholars, and all the king's horses and all the king's men. No one can make a simple experiment that can demonstrate the official force behind the motion.